Welcome to AGU's NASA Learning Area. We will be talking to you about who NASA Heat is, Eclipse involvement, and demos that you can try at home today. Enjoy! NASA Heliophysics Education Activation Team, or NASA Heat, develops engaging educational programs about heliophysics in person and virtually. From running successful nationwide educational programming such as handling NASA Eclipse coordination, to smaller community-centric projects, NASA Heat's varied members provide innovative, engaging programs to reach the nation. Augmented reality, or AR, overlays digital elements to the real world using smart devices. Remember Pokemon Go? Have you ever used a filter in Snapchat or Instagram? Those are great examples of AR and how it works in the real world. AR in education has greatly increased as we learn more about the positive impacts this technology has had on learning. NASA Heat worked with Carroll County Public Libraries in Maryland to create a solar AR visualization. This handheld AR experience allows the user to hold the sun in their hands and watch as two missions, Solar Orbiter and Parker Solar Probe, orbit the sun. The interactive cube, called Emerge Cube, allows users to rotate the information in their hands as they learn more about each spacecraft. Parker Solar Probe, Solar Orbiter, and other NASA missions keep watch of the sun, and you can too, especially with two upcoming eclipses. Let's hear a discussion with Dr. Kelly Couric, Dr. Michael Kirk, Mrs. Shannon Reed, and Ms. Carolyn Ng to learn more.
Good afternoon, everyone. Welcome to all AGU attendees. And today we have three distinguished colleagues in a mini panel discussion on NASA's role in eclipse coordination. And our moderator is Mrs. Shannon Reed. Shannon?
Hi, thank you so much, Carolyn. Welcome. So I would like to first hand it over to our panelists to introduce themselves. Dr. Couric, can you please introduce yourself and your role at NASA?
Hi, my name is Dr. Kelly Couric, and I'm a program scientist at NASA headquarters in the Heliophysics Division, and I study the sun and the effects of space weather.
Thank you so much. And Dr. Kirk, can you please introduce yourself and your role at NASA?
Absolutely. My name is Michael Kirk. I am a research scientist at NASA's Goddard Space Flight Center in the Heliophysics Division. There, I'm working on analyzing images of the sun and understanding how the sun will eventually affect the Earth and be able to make predictions on when that will happen in the future.
Very interesting. Thank you so much. All right, so we're going to go ahead and start with one of our questions that we have. This one is for Mike. Michael, where will we see solar eclipses in North America next?
All right, so the next solar eclipses happening in North America are two. We're getting two back-to-back with each other. Super exciting. Okay, so October 14th, 2023, mark your calendars now. The eclipse will start off coming onto the West Coast and around Eugene, Oregon, and sweep south down through Four Corners area and Texas, and then through Central and South America if you happen to be down there. This eclipse is an annular eclipse, meaning that the sun will block out, or the moon will block out most of the sun, but not completely. This is a preview for the 2024 eclipse, which is going to be a total solar eclipse again. If you remember 2017 and all the excitement around there, this is the sequel. So the 2024 eclipse will come on shore on the west coast of Mexico near Mazatlan, then sweep up through Texas, through the heartland of America, and then up through the eastern seaboard between Canada and the US. So a lot of people will be in the path to be able to see this total solar eclipse. We're super excited about it at NASA, and we're here to get you excited too about it.
Great, thank you so much. I know that I am super excited. All right, so next question is to Kelly. Why is NASA involved in solar eclipses?
NASA's involved in solar eclipses because we want to, first of all, have a safe viewing experience for this amazing natural phenomenon. NASA has scientific interests in understanding the sun and the earth connection, as well as the moon and all the planets, as well as making sure that citizen scientists are involved in these and really allowing others to study the sun and use the eclipse as a way to learn and to make scientific discoveries.
Great. And I believe there is a science activation community that has multiple teams across the country that we can also tap into and get involved with. Is that correct?
That is correct, and that is another aspect that we're very excited about, and to have folks join us from those communities in making sure that the eclipse is really a great experience for everyone.
Awesome. Thank you so much. All right. So everyone remembers 2017 and the excitement for the total solar eclipse and where you were and what you were doing. And I would love to hear what your experiences were for 2017. So if Michael, if you wouldn't mind sharing your experience.
Yeah, absolutely. I had a very memorable experience. Of course, all total solar eclipses are memorable. I was in Madras, Oregon. I'm from Oregon originally, so I wasn't too far from where I grew up. And I led an outreach event there at the Solar Fest in Madras, as well as working with the Warm Springs Reservation to really engage the student population there. And so I visited Madras several times. I happened to be, for the event itself, out in the middle of a field outside of Madras with about 200 Japanese tourists who were also in that field, but had a beautiful view of the eclipse, and it was absolutely breathtaking. The hype, believe the hype. I've seen a lot of celestial events, and some of them you look at and you say, oh, well, that's nice, but this is absolutely worth it. It's worth the trip. It's worth going out of your way to see.
Awesome. Thank you so much. That does sound very memorable. Something you'll never forget. And Kelly, we'd love to hear your experience for 2017.
Well, thank you very much. And I actually was on the other end of the eclipse. So I was in Charleston, South Carolina. So it's very nice. We kind of bookend there. And yeah, it was an outreach event with a couple of thousand people. It was the Eclipse on a Warship. And there were a variety of talks that I gave during the day, working with folks there. And unfortunately, just before the eclipse, clouds rolled in. So everyone was a little, worried that, are we going to see this? And the perfect space in the clouds opened up so that we could actually see the solar eclipse. And so saw my first total solar eclipse. It was completely magical. And as a subject matter expert who's studied the corona and, built satellites to do these things, to actually see the corona with your own eyes was just absolutely breathtaking and such an amazing experience the whole entire day. Learning from others who've seen more eclipses is also just a really great part of this experience of being a subject matter expert at these events.
Awesome. Thank you. That is a great perspective. Michael on one side, Kelly on the other, and then Carolyn and I were both in Carbondale, Illinois for one of the NASA viewing events. Very interesting, very memorable experience, and I will never forget 2017 myself. Okay, so right on to the next question. How can a subject matter expert be involved, Michael?
Yeah, there are lots of ways to be involved and a lot of need to be involved. So if you are interested in being an Eclipse ambassador, to be a leader in your community, to teach other people about the eclipses, we need your help. And this is engagement in all different levels, from libraries and 4-H clubs and boys and girls clubs and Boy Scouts and Girl Scouts and all of the different community groups that you might already be involved in. but also church groups and talking to city councils and engaging across the country, because this event is not only going to be an amazing spectacle, it also is going to take a lot of organization so people know what to expect, can view it safely, and can really enjoy the event for what it is. And so we really need the subject matter experts to get some training from us and to go into their communities and engage their communities, because we can't do this without your help.
Thank you so much. And Kelly, what resources will be available from NASA?
So NASA will have an Eclipse website, and as well as for the subject matter experts, there will be training. So you don't have to go, you don't have to go it alone in being a subject matter expert. And so in order to, and there will be many other things as we get closer. And so we really do want folks to follow us, and that will help us help you be subject matter experts during the eclipse.
Great, thank you so much. Well, that is the last of our questions that we have for this session. So thank you all for being part of this discussion, and thank you to everyone listening to this recording. Stay tuned and follow nasa.gov for more information, and have a great one. Thank you.
Thank you to all three of our panelists and moderator.
Be sure to check out the Indigenous Eclipse Teachings video created by our partners, the Indigenous Education Institute, to learn more about Indigenous ways of knowing and learning about eclipses. Besides watching the sun, NASA missions study Earth and how its magnetic field protects us from extreme solar activities. To help teach students about magnetism amongst a variety of other topics, members of the American Association of Physics Teachers, partners of NASA HEAT, create online learning toolkits called DigiKits for high school and college physics classes.
Today, we welcome two distinguished members of the NASA Heliophysics Education Activation Team. Hello, Ray and Rebecca. Would you please introduce yourselves?
Hi, my name is Ramon Lopez. I'm professor of physics at the University of Texas at Arlington. I work primarily in space plasma physics and solar wind magnetosphere coupling and space weather. I also do a considerable amount of work in physics education.
Hello, I'm Rebecca Vieira. I'm a prior high school physics teacher from the great state of Illinois. And I am currently now with University of Colorado Boulder, but I'm working on this project through my prior affiliation as AAPT K-12 Program Manager.
Thank you. So could Rebecca please tell us about the Magna AR app?
Sure. So the Magna AR app it basically uses just your cell phone that's enabled with AR software. So most modern smartphones and also tablets, they can actually sense the magnetic field around them. We use this information for things like making compasses work, making sure that the screens turn off when a magnetic cover closes on it, things like that. But we can also use it in order to measure the Earth's magnetic field, and then also the magnetic fields of objects that come near it, right? So what Magna AR does is it measures magnetic field while also placing that measurement at a point in three-dimensional space. So it uses things like motion detectors, like accelerometers and gyroscopes, and then it actually places vectors in 3D space that show the direction of the magnetic field. So you can really get kind of an immersive experience and understand what the magnetic field around you and your environment looks like coming from the Earth, but also what smaller magnetic fields like around a magnet might actually look like, again, in 3 dimensions. So it's quite a bit more interesting than just looking at iron filings around a magnet.
That sounds great. So how can this app be used to introduce planetary magnetism in the physics or astronomy class, Ray?
So let me give a little bit more context, because Rebecca and I are part of a team that actually I lead, which is from the American Association of Physics Teachers, that is working in partnership with NASA as part of the NASA HEAT team, the Heliospheric Education Activation Team. And we have been working to develop materials that could be used in introductory physics courses at both the university and also the high school level around basic physics concepts, but using heliophysics as the context for these particular activities. Magna AR is a tool that is being developed under a separate grant from the National Science Foundation that Rebecca is the principal investigator for that grant, and I'm part of her team on that particular effort. And so we've combined the Magna AR with our work in heliophysics for NASA HEAT to create some activities where you can use your smartphone as a magnetometer and study various topics related to magnetism. One of the kits that we've developed, one of the instructional packages that we've developed is around planetary magnetism, where you begin by studying the magnetic field of a single magnet, and you learn about the North Pole and the South Pole and what the magnetic field looks like. Magna AR allows you to visualize that. Then we put it in the context of a planet X, which doesn't have a simple magnetic field like the Earth with just a North and a South Pole. Actually, Earth's field is a little bit more complicated than that, but fundamentally, it's just a North Pole and a South Pole, like a big bar magnet in the Earth. But not all planets have that kind of magnetic field. And in particular, Mars doesn't have an organized dipole magnetic field. It has lots of remnant crustal magnetism, magnetic materials that were sort of frozen into place long ago. And so there's no straight north and south in Mars. So we create, or have the students actually create such a model magnetic field with a small globe that they can put magnets on the inside and investigate that and compare it to actual scientific observations of the Martian magnetic field. We also have an activity on magnetic energy, where you use the Magna AR app to actually measure the changes in magnetic field as you push magnets together or move them apart, and you learn about what's the energy in the magnetic field. And energy in fields is an important concept in the next generation science standards, but it's a very difficult one to communicate to students. And we believe that the activity that we've developed provides an excellent opportunity for students to understand energy and work in magnetic fields.
Sounds very interesting and useful. So you mentioned about the AAPT DigiKits. What are they, and where can you find them?
I'll go ahead and share with you where you can get access to these, and specifically to the one that Ray was talking about. If you go to the aapt.org website, you will find a whole slew of resources focused on solar activity, solar eclipse, and exoplanet themed resources. I'm going to share with you the one that is related to Magna AR that Ray was talking about. And I know we're talking about planetary magnetism, but we're also really thinking about that interaction with the sun, in our case, if we're looking at Earth, and of course how the magnetosphere protects life on Earth. So if you go down to the bottom, it will take us to something called a DigiKit. A DigiKit is a full package for educators that links the activity that we've created with lots and lots of great resources that are out there, including many NASA resources. If you click on the Guided Inquiry Lab, you can actually download the activity that Ray was talking about. But in addition to that, we have lots of vetted resources put together by AAPT staff that help teachers and students deepen their understanding about the Earth's magnetic field using simulations, or about magnetic fields in general. There's lots of great resources available about what's going on with the Earth's magnetic field, how might that affect life on Earth, why, again, that shielding matters. as well as a number of other additional tutorials that come from NASA in this case, activities, teacher background, and then finally, for those who might be using the next generation science standards, we have links to all of the specific disciplinary core ideas, science engineering practices, and cross-cutting concepts. So we have this not only for the activity that Ray had mentioned, but for a number of other different resources as well that are relevant to heliophysics. So please do visit that website to learn more.
Thank you. So how are the DigiKits related to NASA sciences?
We use heliophysics as the basic context for activities such as the planetary magnetism activity or energy and magnetic fields, which energy and fields is a core concept in NGSS, and we use heliophysics to motivate an understanding of that. And things like force and motion. I mean, motion of objects is a fairly fundamental piece of physics. We've got a DigiKit on the motion of a coronal mass ejection, where students are following a coronal mass ejection through space. So we're using fundamental science that's being done in heliophysics to illustrate basic physics that teachers can teach in the classroom.
Thank you so much to Dr. Ramon Lopez and Ms. Rebecca Vera.
You can find more magnetism activities for grades 3 through 12 at the following URL. NASA Heat hopes you enjoy our activities. Please contact any one of us for questions or comments. Thanks, and enjoy the rest of your time at AGU.